Okay, I'm not in class today, so I'm making a video of the lesson. That way you guys can still learn some math while I'm gone. All right, today we're just going to talk about Unit 3 vocabulary and then do a little color sheet to talk about some of the vocabulary and really set that in our brains. Okay, so this is the blue sheet we taped down yesterday. So if we open that, then we see the vocabulary word, the definition, and the picture. So here we have our vocabulary word is slope. We already know that slope is a measure of the steepness, or flat, I guess, of a line on a graph. You guys know that to find slope, we just use rise over run. The picture I'm going to pick to draw for slope, a picture that reminds me of slope, is Slope Dude's Adventures Skiing. Remember, he goes uphill and says puff, puff, positive, because that's an uphill positive line. Then going downhill skiing to the right, he says nice, negative, because it's really fun. It's nice to go down the hill where the slope is negative. Then on the long flat part, he says this is zero fun. This is zero fun. This is zero fun. Because you know the slope of a horizontal line is 0. And when he falls down the cliff, so frightened is he that he says the worst curse word in all of math and algebra, undefined. So that's the picture I picked to use for slope. Remember, slope is just plus or minus rise over run. Plus or minus rise over run. The y-intercept we started talking about yesterday, and that is just the location of the point where the graph of a line crosses the y-axis. So if I had a graph, here's my x-axis and here's my y-axis, and I had a line that looked like this on my graph. To find the y-intercept, we practiced this yesterday, we traced the y-axis until we found the line, which is right here. So we called that B. There's already a graph here, so we're going to trace the y-axis. Mr. Garrett, if you'll pause the video and wait about maybe 30 seconds, let the students find the B value, the y-intercept of this axis. Okay, so you're tracing the y-axis until you touch the line, which happens right there. Okay, and remember to write the ordered pair. Remember, those are x comma y. On the y-axis, the x value isn't negative, and it's not positive. The x value side to side is 0. So to write the ordered pair for this, we have 0 followed by a number for the y value. Make that note over here at the y-intercept, 0, comma, some number. That number is just B. Yesterday we learned that slope was the letter M. You also know it's A in your calculator. Later on this year we'll get to use K. And yesterday we also talked about the y-intercept was the letter B. Only one letter for the y-intercept. Okay. Yesterday we talked about a linear equation. This is just any equation whose graph is a straight line. Straight line. So that's where I have a linear equation, and when I put it on a graph, it just makes a straight line. Maybe this is a straight line. I can have something that looks like this. Those are some good pictures of linear equations because it's some type of equation where the graph is just a straight line. And the most popular form of linear equations is slope-intercept form, which we learned yesterday. It's just a type of linear equation. Slope-intercept form meant that the slope came first in your equation, and the intercept came next in your equation. The y-intercept came next in your equation. Remember that y and x get to stay letters. Y and x just make an ordered pair. M tells you the slope. You can also use A. And B tells you the y-intercept. If you have a plus B, then the y-intercept was positive. If you have a negative B, then the y-intercept was negative. So we need to know that slope-intercept form of an equation is just a linear equation. It's just the equation of a straight line. Our last word is a system of equations, and that's just two or more. Let me pause this video real quick. Sorry. Okay, I'm sorry. I want to change the wording of this so you can cross out the with the same blank. I just want to say two or more linear equations. And I want to add a word in system of equations before equations write linear, so this is a system of linear equations. A system of linear equations is two or more linear equations. That might look like a group of y equals 2x plus 4 and y equals negative 3x minus 8. Here I have two linear equations that are in slope-intercept form. So I have a system of linear equations. I have two slope-intercept form equations here. So another one I could say, another system of linear equations, I could say y equals 1/2 x minus 2. We could say y equals negative 8x plus 7. You could say y equals 1/3 x minus 1/4. That's your vocabulary for this unit. Mr. Garrett, can you make sure that all of the students have their vocabulary filled out? I'll be checking this when I get back to class as well on Monday. That was page 38. Now let's go to page 39. I told you guys yesterday that for this page you needed to have 3 colors. You need to have 3 colors. So we're going to learn 3 more vocabulary words: linear, nonlinear, and undefined. The 3 colors I'm going to use are pink, purple, and I'll use yellow also. Use yellow. Pink, purple, and yellow. And I'll color linear functions. Linear functions will be pink. Non-linear functions will be purple. And undefined functions will be yellow. Undefined functions will be yellow. Before we get to coloring, I want to talk about what linear, nonlinear, and undefined mean. You guys know undefined already. Undefined is just a line that goes straight up and down. It's when the slope, or m, or a, or k, is undefined. Linear, the definition is kind of in the word. L-I-N-E is how linear starts out. Linear just means a straight line. It has to be straight. And if you have your pencil to the right, your pencil just points one direction on the line. It never is undefined. Never is undefined. Linear is a straight line in one direction, but it cannot be undefined. Now, nonlinear just means it is not a straight line. It might change directions. It's never going to be undefined, though. So nonlinear is also never is undefined. Never is undefined. This first box here, here's my x-axis, here's my y-axis. And going from left to right, if I followed this line, I'd only ever travel in one direction. I'd only ever travel to the right if I followed that line. Or I'd only ever go up, I'm sorry. Since this is a straight line, and if I followed it going left to right, I'd only ever go up. So it's a straight line in one direction, and it's not undefined, then this is linear. This is linear. Looking at the next box, I have a line. I'll trace it. And if I follow, sorry, here's my x-axis. Here's my y-axis. The y-intercept of this line, would be if I followed the y-axis until I crossed the graph. Right here, that would be the y-intercept. If I follow my graph from the left to the right, I'm going down, right? But then I curve and I go up. So one, this is not a straight line, but it also changes directions. Since this is not a straight line, and it does change directions, and it's not undefined, I can say this is nonlinear. This graph is nonlinear. The next box, work to find the y-intercept of the line first. Work to find the y-intercept of the line. Remember, to find the y-intercept, you follow the y-axis until you are on the graphed line. So the y-intercept is right here. That's the point 0, 0. Your b value is always the y value, so I know here that b equals 0. Anyways, the goal of this page is linear, nonlinear, or undefined. So if I were to trace the graph here, the line on my graph, from the left to the right, I only ever go up. Since I'm only ever going up, that is a straight line in one direction. This is not undefined because it's not vertical. So I know that this is a linear function. That line is linear because it's a straight line that only ever travels up, and it's not undefined. Looking at the next box to the right, if I wanted to find the y-intercept, I've got one here, but I also have one here. Linear equations never have more than one y-intercept. Nonlinear things might have more than one y-intercept. We're not going to learn about nonlinear functions this year, other than just determining whether it's linear or nonlinear. This is nonlinear because it is not a straight line, right? It curves. Also, if I were to follow this, going from the left to the right, I'm going kind of down, and I go down again. But I'm changing directions. I'm going this way, and then I'm going this way. This is not linear, because it's not a straight line. not a straight line means it's nonlinear. Not a straight line, nonlinear. Try this one on your own real quick. If Mr. Garrett will pause the video, and then you guys can try that on your own. Wait about 30, 40 seconds. So hopefully you guys saw this is not a straight line. It's a whole circle. So this is nonlinear. So I'm coloring mine purple because I said nonlinear was purple. It is not a straight line. It's also not undefined though. Looking at the next graph, I want to find the y-intercept. Just for fun, I want to find the y-intercept. Here's my x-axis, here's my y-axis. If I want to find the y-intercept, I trace the y-axis. Tracing the y-axis, there's the line I'm on. So that would be the y-intercept of the line. If I were to trace this line going from the left to the right, the line only ever travels going to the right. This is a straight line in one direction. The slope, think about whether this is 0 or undefined. This is a 0 slope. Since the slope is not undefined, it is a straight line, and it only goes in one direction, then this is linear. Here's my line, and it's linear. Look at the next two on your own. Mr. Garrett, if you'll pause the video for maybe a minute this time. So you guys saw that this line is pretty curvy. Since it is not a straight line, I'm thinking maybe it's nonlinear. This is also not undefined. Since it's not undefined and it's not a straight line, I know that this is nonlinear. Same here on the next graph. It's very curvy, it's not a straight line. However, it's not undefined. So it's never undefined, and it's not a straight line, so I know that this is nonlinear. Looking at the next set of 4, you guys see the curve here. Since it curves, that means this is not a straight line. This is not an undefined line, which means this is nonlinear. Looking at the next graph, I do have a straight line. The straight line is vertical though. And we know that a vertical line, write this down, vertical line, the slope is undefined. What a bad word. Undefined. Since this is undefined, it cannot be linear, it cannot be nonlinear, because those are both never undefined. Which means I'm coloring this yellow because it doesn't fit with linear or nonlinear. This is something all on its own. This is an undefined line. Mr. Garrett, if you'll pause the video and let them try the next two on their own. Okay, so here I've got a line, and if I follow it from the left to the right, the line only travels in one direction. It's a straight line. It goes in one direction if I follow it from left to right, and it's not undefined, which means this is linear. Next, we've got a curve here. Since it curves, that means this is nonlinear. You can also see the change in direction if I'm following this from left to right. First I'm going down, and then I'm going up. This is nonlinear for a couple of reasons. One, it's curvy. Two, it changes direction. Next we'll look here. We've got a straight line from left to right. This line travels in one direction, and it has a positive slope. It's not undefined. So it's a straight line, travels in one direction, and it's not undefined. That means this is linear. Next I've got a line, and if I trace the line, it only ever goes down from left to right, which is kind of good, but it has a little bit of a curve. So this is not a straight line, however it's not undefined. So that means this is nonlinear. Not linear, so nonlinear. Next one's tricky. Mr. Garrett, go ahead and pause the video and let the kids think about whether they think this is linear or nonlinear. Okay, if I trace this line going from left to right, this is a straight line, right? So if this is straight, so I'm thinking maybe it's linear. If I trace the line, it goes down, but then out of nowhere I start going up. Since this is, yes, a straight line, but in more than one direction, this is nonlinear. The last one, we've got a straight line. The slope is, because it's horizontal, the slope is 0. It's a straight line, it's not undefined, and it travels in one direction from the left to the right only, meaning this is linear. Mr. Garrett is going to pass out a sheet of paper that has a bunch of graphs on it, and I just want you guys to determine whether the graph is showing you something linear or nonlinear.